Right, so this is another one of those crazy projects that I tend to get roped into. The guys over the way from my workshop do concrete castings, and basically they have a big bed into which they pour concrete and make concrete beams. But between the beams they have to have a bung to stop the overspill when they pour the concrete, so they're basically able to make beams of whatever length they require. Now inside the beam are some steel reinforcing wires. So this bung here, and I have an example, has various slots in it which allow the reinforcing wires to drop in, and then this will sit this way and you'll have one beam here and one beam here. And you may be able to see just about that there is a very slight inverse taper on these, which basically means the only way they can get these out of the mould is by knocking them down. And what they're currently doing is using a kind of T-piece pogo stick, if you like, which has a couple of prongs on the end, and there's a bloke just basically bouncing up and down on this thing, putting all his weight behind it, which kicks these things out slowly but surely. Now that's A, quite a painful process, and B, it's taking them rather longer than they would like. So the gaffer's been over to see me and said, "You're the local inventor on the block, can't you come up with something that will do the job a little bit quicker and easier?" So I'm seeing what I can come up with. After a bit of head scratching, I thought one simple way of doing it might be to basically make a supersized automatic centre punch. These things have been around since the 1800s, and they're actually quite a straightforward design. I think there's quite a few patents out there in the archives, but essentially it's just an end cap and a main firing spring, and then a central coupling barrel which has a little bit of cleverness inside, but nothing major, a firing anvil with a hole in the middle, which is quite important, and then at the other end there's just a return spring, a guide pin which is quite important, and then just the punch at the far end and another housing. The main business end of it are these two components here, and the idea is this pin can actually wiggle slightly within the barrel, and it has a slight taper on this shoulder, and the idea is that this thing will initially catch on the edge, and then as the pin moves up it straightens up by engaging with a square section inside the barrel, and as soon as it aligns up it drops into the hole, and the main spring can fire the anvil forwards and trigger the punch. So having taken that apart and seen how it works, my next stage was try and build a bigger one. So this is essentially just a copy of that but scaled up by a factor of 2. It's using whatever springs I had lying around. It's not quite perfect because I foolishly decided to modify it a few times after I'd originally made it, but if you can get it to catch, it does work. So nothing terribly glamorous about that. If I take it apart, we can have a look at the bits inside. There's just the pin and the housing, nothing clever there, a return spring and this guide pin which does all of the hard work, and then at the other ends there's just the anvil in there with its hole. So having got that to work, the next stage is to scale things up slightly, and this is basically a full-size diagram of what I'm hopefully going to be making, and in here we can see a rather larger version of the pin I've made so far with the shoulder, and you can see how there's a slight lean on it, so that when the thing is pushed down, this punch pin is going to push against this main firing pin here, engage right on the edge of the anvil, and then continue to push it up against the spring until it bites here against the edge on the coupler, where the shoulders are going to align it, and then the pin should fire forwards. This has all actually had to be designed around the main firing spring, because there's only so many different springs you can get off the shelf, and obviously you can get springs ordered to custom jobs and so on, but it's just a little bit easier if you can find something that will do the job. So the return spring isn't critical, that only needs a few kilograms of tension in it, but I calculate this spring to mirror the T-bars that they're currently using. That probably needs to be compressed with about 30 to 40 kilograms, so that when it fires we get a shock load down which should be somewhat greater than 30 to 40 kilograms. In theory it should be up to double that as an impact load, and that should easily be enough to dislodge one of these. So all I've got to do now is wait for the bits and pieces to show up, start machining all of this down, and we'll see if it actually works. But that's a project for the next couple of days.